This is one of probably many videos for September 14th, 15th. We spent today kind of reviewing, we've looked at multiple transformations over the past few classes. Today we're going to put all of those transformations together and try to graph them. So that's what we did in class. Now, we didn't get through as much as I expected, but that's okay. In class, every class did numbers 1 and 2 on the board. Some classes did 3, some classes did 4. So what I'm going to do is I'm going to try to solve 3 and the rest of them, put them online as an extra resource for y'all. So let's start here. What I've suggested, if you don't like this suggestion, maybe you can talk to me, figure out another way to graph them. I suggest to start by looking at the period and amplitude. So period. So we know that the period is going to change if x is being multiplied by anything. But here, x is alone. It's not being multiplied by anything. So our period does not change. Our period stays as 2 pi. And our amplitude, you might want to refresh looking at your previous notes, but our amplitude changes if our parent function is multiplied by anything. So because our parent function is being multiplied by 4, then our amplitude becomes 4. Okay. So out of all of our values, we've dealt with a 4. The 3 pi over 2, that's telling us that our function is actually shifting to the right 3 pi over 2 units. But let's go ahead and graph this on our coordinate plane and then shift. That's what my suggestion is, to figure out period and amplitude, graph that in any reflections, and then shift. So our largest value is going to be 2 pi. Now we have pi here. Pi over 2, 3 pi over 2. Same thing in the negative direction. I'm not going to make all of the points. Okay. Now, that's our x-axis. Now let's look at the y. Now our amplitude is 4, which means we're stretching our function vertically by a factor of 4. But because we didn't add or subtract anything outside of our parentheses, we're not shifting the entire function up or down. So we can just go to 4. So let's say 1, 2, 3, 4. And if we went in the negative direction, okay. Now, this is where knowing our parent functions comes in handy. This is how I suggested doing it in class. Again, if you wanted to do it a different way, that's fine. But cosine, our cosine parent function, quote unquote, starts at 0, 1. But if it has an amplitude of 4, really what we're doing is whatever our parent function is being multiplied by, we're going to multiply all of our values by that number. So if it's 0, 1, we're going to multiply 1 by 4. So our new point is going to be here at 4. Parent function at pi over 2, the function is 0. 0 times 4 is still 0. So that point is going to stay here. Similar thing with negative pi over 2. Pi, cosine at pi, the parent function, its value is negative 1. But if I do negative 1 times positive 4, that would give me negative 4. So our function is being stretched out here. 3 pi over 2, our function is 0. 0 times 4 is still 0. At 2 pi, cosine, the parent function's value is 1. 1 times 4 would give us 4. So what I'm suggesting is creating this, making this our dotted line. That's the suggestion that I'm making. If you want to find another way to do it, that's fine. But this way we can have one dotted line and solid line. It's not so cluttering. So let's check real quick. We didn't need to reflect. There's no negative. Our amplitude should be 4. From here to there, 4. Here to there, 4. So we're good. And our period, 2 pi. So from here, we repeat starting there, 2 pi, so we're good. All we have to do now is shift to the right 3 pi over 2 units. Well, if I'm here at 0, I see 3 pi over 2 is there, so I'm going to shift this to 3 pi over 2, so it's going to be right there. Or in other words, 3 tick marks. So if I take this point, now I'm shifting it 3 pi over 2 to the right, or 1, 2, 3 tick marks. This point, 1, 2, 3 tick marks. This point, 1, 2, I run out of tick marks, but let's say just 3 right there. And so our new function would look something like this. And this would continue on. This would be down at 4. Is that right? Yeah, down to 4, back to 0. So really, if we want to continue on, we could do that. And it's a little sloppy right now, but okay. But what I'm suggesting is period and amplitude, doing that at once, and then shifting after that. So let's see about this one. Now for number 4, what we have to do is, I'm going to do this before we do anything, is we have to factor. So similar to what we did on September 12th or September 13th, x here is being multiplied by 1/4. So what we have to do is factor out a 1/4. Now x is on its own. Plus pi over 4 is here, so I'm still adding pi over 4. But because I factored out a 1/4, I'm going to divide pi over 4 by 1/4. Or, since we're dealing with fractions, multiply by the reciprocal. So from here to there, that's the reciprocal, because we're really dividing. And so what we end up with is sine of 1/4 x. Here we can already see if we multiply these 4's, divide out. So plus pi. Okay. So now we have x on its own, if you will. Now we can figure out our period. Well, our period, the period of the sine parent function is 2 pi. And then we're going to divide by whatever x is being multiplied by. Here, x is being multiplied by 1/4. And this one, x was being multiplied by 1. So we don't have to worry about it. But here, x is being multiplied by 1/4. We're really going to divide by 1/4. But to divide by 1/4, we're going to multiply by its reciprocal, 4 over 1. Which would give us a period of 8 pi. And then our amplitude here, sine is not being multiplied by anything in the front, so our amplitude is 1. Now what we can do is say our largest value, the period was 8 pi, so let's say 8 pi, negative 8 pi, 4 pi, 2 pi, and here our amplitude is 1. We're not moving up or down, we're not adding or subtracting anything outside the parentheses, so let's just keep 1, negative 1. So now let's look at the sine parent function. Basically, we're doing the same parent function on here, just our scale is different. We quote unquote start at 0, go up to 1 at this next tick mark, go down to 0, up to 1, or down to negative 1, up to 0. Okay? Just the scaling is different, so we need to be careful there. So we've taken care of our period and our amplitude. Now I'm going to bring this sine over here. We have sine and this plus pi means we shift to the left pi units. Well, if I'm starting at 0 and I shift here, I shift it to the left 2 pi. which means if I shift halfway, that should be shifting to pi. So if I shift all the way here, that's 2 pi to the left. So I'm going to go halfway. That's pi. So here, if I shift all the way there, that would be 2 pi. So I shift half of that length would be pi. Same thing here. 2 pi, or 4 pi to 2 pi would be 2 pi. So I'll just go there. This point, shifted pi. This point, shifted pi units. And then we draw our function. So that's our function. So we need to be careful if x is being multiplied by a value, we need to factor that value out to get x on its own. Once we have x on its own, then we can figure out how to shift the function and draw that function. Again, on these two, what we're looking at, what I am suggesting is to figure out the period and amplitude. Let's use that first to go ahead and draw the dotted line function, and then we can move left or right to create our solid line, our actual function. That's what I'm suggesting. If you have questions on this, please email me, contact me. I'm going to do another video to do 5 and 6. Hopefully I can do 5, 6, maybe 7 and 8 on that. Maybe not. But keep watching the videos to get all problems from today.